So for the remainder theorem, if you take a polynomial and you divide it by some factor x minus h, the remainder is f of h. That means you can take a polynomial f of x and you can write that as x minus h, what you're divided by, the divisor, times some quotient q of x plus f of h, which is your remainder. Now that seems like, well, so what? Well, it means if you divide by x minus h, let's say you're divided by 3, then that means that f of 3, if you substitute 3 into your original polynomial, that will tell you the remainder. Here's a nice proof of the remainder theorem. So if f of x is a polynomial and we're going to divide it by x minus h, then clearly you'll have f of x equals x minus h times q of x plus some sort of remainder. But let's say we made let x equal h. Well, if x is equal to h, then you've got f of h equals h minus h times q of h plus r. So f of h equals r. So we've just proved that the remainder is f of h. So clearly, if we want to do 33 divided by 4, we would say that 33 divided by 4 equals 8, because 4x is 32, plus an extra 1, so the remainder of 1. So you've got the divisor, which is 4, times 8, plus an extra 1. This bit here is your remainder. This bit here would be your quotient. The divisor times your quotient plus the remainder. It's exactly the same thing as when you divide algebraically. Find the quotient and the remainder when this is divided by x add 2, then express it in the standard form, x add 2 times quotient plus remainder. Let's find the quotient and remainder first. So if we're divided by x add 2, if we substitute minus 2 in, that will tell us the remainder, and if we use nested form, it will tell us straight away also the quotient. So we're going to substitute f of minus 2. Using nested form, we've got 3x cubes, we've got 0x squareds, we've got minus 5x's, and we've got plus 7, and we're dividing by x plus 2, so substitute minus 2 in. 3 times minus 2 is minus 6, minus 6 add 0 is minus 6, minus 6 times minus 2 is 12, 12 take away 5 is 8, 12 take away 5 is 7, 7 times minus 2 is minus 14, minus 14 adds 7 is minus 7. So the quotient, well, this bit tells me my quotient is going to be 3x squared minus 6x plus 7, and my remainder is minus 7. So now to put it in the form it wants, f of x then equals x add 2, our divisor, times our quotient, plus our remainder, minus 7 at the end. Find the quotient and the remainder when f of x is this, and it's divided by x add 1, and express it in the standard form, x add 1 times quotient plus remainder. So if it's divided by x add 1, we should substitute f of minus 1 into the equation, because f of h will be minus 1. So we've got 4x cubes, we've got 1x squares, we've got minus 1x's, and minus 1. Remember, this is my x squared cubed x squared, x and number. Substituting minus 1 in. So we drop the 4 down. 4 times minus 1 is minus 4. Minus 4 add 1 is minus 3. Minus 3 times 1 is 3. 3 minus 1 is 2. 2 times minus 1 is minus 2. Minus 2 take away 1 is minus 3. Quotient. Remainder. So our quotient is 4x squared minus 3x plus 2, and our remainder is minus 3. So f of x is equal to x add 1, 4x squared minus 3x plus 2 3. And we're done. As we clear our master today, we'll be looking at the remainder theorem and how to write polynomials in the form divisor times quotient plus remainder, looking at the fact that if we know we divide a polynomial by x minus h, the remainder is simply a function of h f of h. Take care, stay safe and goodbye.